The first sort of summary statistic we're going to talk about is a measure of center. And in many ways, if we want to summarize our data using just one number, a measure of center is what we want. What a measure of center does is it tells us what is a typical value for our data set. Why measure of center? Well, if we imagine our data as spread out along a number line, it might look something like this. If we have data set 1, well, we have a value here, value here, we have a value here, a value here, a value here, a value here, and another value here. This has some sort of a middle, maybe somewhere around here-ish, right? There's definitely a point that's in the middle of that picture. Or if we look at data set 2, which represents the credit loads of 11 full-time students. Well, we have a value here, and another one here, another one here, one here, one here, yet another one here, one here, one here, one over here, and one over here. Again, this has a middle somewhere. Though, man, that big pile at 15, it feels like we should take that into account somehow. We could draw pictures like this for any of our data sets. We probably wouldn't want to do it for the one that has 1,000 values. But the question is, how do we figure out exactly where that middle is? The easiest measure of center to figure out is what's called the midrange. The midrange is the number that's in the middle between the largest and smallest values. Now, how do we find the number that's halfway between two others? Well, you may recall from an elementary geometry class or something. To find the value that's halfway between two others, we just add them up and divide by 2. If you like memorizing formulas, you can memorize that formula for the midrange. Otherwise, just remember it's halfway between the two values. So looking at data set 1, the midrange is, well, the largest value is 11, the smallest value is 6, so that's 17 over 2 is 8.5, which is actually about where we drew that arrow. Oh, that's interesting. What about data set 2? For data set 2, the midrange is, well, the largest value is 17, and the smallest value is 12 divided by 2. So what, 29 divided by 2 is 14.5. And again, that's pretty much where we drew the arrow. Right? So it feels kind of good, this mid-range thing. But now let's look at it for data set 3. For this data set, we've got a value here, one here, one here, One here, one here, 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 and here. So it really looks like we've got a bunch of values clumped together over here. And then they're kind of more spread out here. And we'd kind of like those to be split up almost evenly. So if we're going to come up with kind of an intuitive middle here, it might be somewhere around here. But of course, that's not what we get from the mid-range. The largest value is 73. The smallest is 61. So we have what? 134 over 2 is 67. The mid-range is over here. But we feel that the weight should be a little bit more over to the left because we've got that big clump of data. It's even worse for data set 4, where the mid-range, still easy to find, is the largest value plus the smallest value divided by 2. So that's 6 divided by 2 is 3. That's here. But looking at these frequencies, right, it looks like way more people have fewer than 3 siblings than have more. It feels like 3 is already starting to be kind of a weird value. Right? If we wanted to be representative, we definitely want to be more like 1 or 2. So, what is this saying? The mid-range is a good first measure of center. It's intuitive, it's easy to look and see how that really is the middle value. It's easy to calculate, even for our really big data set. But on the other hand, it ignores most of the data. So, like, it ignores any numbers between the smallest and the largest. That feels really weird. And in fact, if the data are not spread out evenly, it starts to be weird. It doesn't match our intuition if the data are not spread out evenly. In reality, we'll really sort of only use the mid-range as a quick and dirty estimate for our measures of center. We will want a different measure of center in most real applications. In the next video, we'll meet some additional measures of center that we might use in a more realistic application. And we'll also see how to get the calculator to work out a lot of the arithmetic involved in finding them for us.